There's a cell in your artery wall right now. If you have any plaque at all, the cell is in it. And depending on the signals it's receiving from your body today, it is doing one of two radically different things. It is either building plaque larger, swallowing oxidizing LDL, becoming a foam cell, releasing inflammatory cytokines that thin the fibrous cap until it's ready to burst. Or it's dismantling your plaque. It's loading the cholesterol from the plaque onto the HDL cholesterol, secreting collagen to reinforce the cap, clearing the debris of dead cells that would otherwise become the necrotic core. It's the same cell, but completely opposite outcomes. And the switch between them is not genetic, it's not fixed. It responds to what you eat, how you move, when you fast, and what your blood looks like when that cell wakes up each morning. I'm going to show you exactly what this cell is, how it gets switched to the wrong setting, and the 5 specific interventions that can flip it back. What's a macrophage? The macrophage is your immune system's first responder and garbage truck combined. It circulates in the blood as a monocyte, a white blood cell. When it senses inflammation anywhere, it migrates to that site and differentiates into a macrophage. In the arterial wall, macrophages sense the presence of oxidized LDL trapped in the inner lining of the blood vessel wall called the intima. They arrive to clean it up. Their job, as originally designed, is protective. The problem is what happens when they are overwhelmed. When there's too much oxidized LDL, when the environment is saturated with inflammatory signals, the macrophage becomes what is called a foam cell. It gorges on lipid it cannot clear. It swells, it loses its ability to migrate out of the blood vessel wall, and it becomes a building block, a plaque, instead of a solution for it. But the macrophage retains its plasticity, meaning it could be reprogrammed. And that reprogramming is the most compelling frontier in cardiovascular biology right now. What is the M1 macrophage? This is the plaque builder. The M1 macrophage is the classically activated in the inflammatory state. It is triggered by oxidized LDL, lipopolysaccharide, and a cytokine called interferon gamma. When it activates, it produces a cascade of inflammatory molecules. TNF-alpha, interleukin-1 beta, interleukin-6. These are markers of inflammation for heart disease. These cytokines recruit more monocytes from the blood into the plaque, amplifying the inflammatory response. The plaque grows. The M1 macrophage also secretes enzymes called matrix metalloproteinases. These enzymes degrade the collagen, which are proteins that hold things together. These are the exact enzymes that thin the fibrous cap of a vulnerable plaque. And crucially, the M1 macrophage downregulates ABCA1, which is the transporter responsible for offloading cholesterol from the foam cell onto the HDL. So without the ABCA1 transporter, the cholesterol stays trapped inside the plaque, the foam cell cannot clear itself, and the plaque is locked into place and growing. On the other hand, there's an M2 macrophage. What is the M2 macrophage? This is the plaque remover. The M2 macrophage is the alternative activation state. It is triggered by interleukin-4, interleukin-13, and interleukin-10, the anti-inflammatory cytokines associated with tissue repair and wound healing. The M2 macrophage does the opposite of everything the M1 does. It secretes interleukin-10 and TGF-beta, which suppresses the inflammatory cascade. It secretes collagen, which thickens and reinforces the fibrous cap. It dramatically upregulates ABCA1 and ABCG1 cholesterol transporters, which open the cholesterol transport out of the plaque and loads the cholesterol lipid onto the high-density lipoprotein, HDL cholesterol. In regression studies of atherosclerosis, M2 macrophages are consistently enriched in shrinking plaques. When scientists cause rapid LDL reduction in mice with advanced disease, the plaques shrink. And when they examine those shrinking plaques, they find a striking shift. M1 markers falling, M2 markers rising. The macrophages have been reprogrammed, and the switch is real. The most important finding in this entire field of research is this: Macrophages retain their plasticity, meaning the ability to change forms even after it's been decided polarization. So a fully committed M1 macrophage can be converted into an M2 macrophage by exposure to IL-4. The switch is bidirectional. The macrophage responds to its environment, not to its history. This means the balance of M1 to M2 macrophages in your plaque today is not fixed. It is actively being set by the signals your body is generating right now. So if you have high LDL, high oxidized LDL, a lot of saturated fat, chronic glucose elevation, inactivities, these push the balance toward M1 macrophages. Plaque grows, caps thin, inflammation spirals. It's a vicious flywheel. If you remove the oxidized LDL substrate, reduce systemic inflammation, generate the anti-inflammatory signals, and the balance shifts towards M2, plaque stabilizes, caps thicken, cholesterol efflux, transport accelerates. So what are the 5 things that flip the switch from M1 to M2 macrophages? Number 1, eliminate oxidized LDL at the source. The single most powerful driver of M1 polarization is oxidized LDL in the arterial wall. What does this? A whole food plant-based diet with zero saturated fat reduces LDL and susceptibility to oxidation simultaneously. Less oxidized LDL, less M1 signaling. Number 2, intermittent fasting. Fasting triggers a metabolic shift from glycolysis to fatty acid oxidation. M1 macrophages run on glycolysis. M2 macrophages run on fatty acid oxidation. So when you fast, you change the metabolic substrate in a way that structurally favors the M2 energy pathway. Number 3, high-intensity exercise. A 4-week aerobic exercise intervention showed significant systemic increases in IL-10, arginase 1, and CD163. These are all M2 signature markers. When M1 cytokines, TNF-alpha, interferon gamma, IL-1 beta, and IL-6 fell significantly. So exercise is not just a cardiovascular intervention. It's a macrophage reprogramming tool. Number 4, pomegranate juice and polyphenols. Pomegranate polyphenols promote M2 macrophage polarization through PON1 activation, reduction of oxidized LDL uptake up to 90%, direct anti-inflammatory signaling through the PPAR gamma pathway. Curcumin, resveratrol, and quercetin show similar M2 promoting effects. Number 5, LDL cholesterol reduction. Reducing LDL substrate directly changes the microenvironment inside the plaque. Animal models consistently show that rapid LDL reduction causes a wave of M1 to M2 conversion in existing plaques within weeks. The macrophages that were building the plaque become the macrophages removing it. And my own protocol is through the M2 lens. When I look at my imaging results through the lens of this research, I see something the numbers alone do not fully capture. My FFR improved from 75% to 80%, from stentable to normal. My bilateral CMIT and my carotids reduced 53% in 3 months. All the plaque disappeared in my carotids. The anatomical stenosis did not dramatically change in my coronaries, but the functional physiology has been improving significantly. The whole food plant-based diet is reducing oxidized LDL inside the plaque microenvironment. The high-intensity exercise is systematically shifting the M1 to M2 balance. The fasting is shifting the metabolic substrate from glycolysis to fatty acid oxidation, and the pomegranate juice is activating the PON1 pathways that promote M2 polarization. So I'm not just lowering a lipid number, I'm reprogramming the immune cells inside my plaque from plaque forming to plaque removing, switching them from the phenotype that builds to the phenotype that repairs, and the imaging is beginning to reflect that shift.
These videos save lives. Like, subscribe, share it with someone you love, and ask your questions below. Together, we will save lives. For my up-to-date learnings and more, visit me at ham.com.